I was so mad. You know how I have my MacBook? Well, I finger slided out of my homework quiz somehow because I'm totally hand-eye coordinated like that. And I got like D's on both of them, and I just like called her in tears, and I was like, I also failed two of the homework assignments because I didn't read the due dates right. And I was like, I'm gonna fail your class. She's so sweet. She's so nice.
Yeah, she's like super understanding. There's been a couple times when I've like exited out of a quiz too. And I'm just like, oh, it's an accident, all these things. And she's like, oh, no problem. I just renewed it for you. And I was like, oh my gosh. So, yeah, she's like super gracious.
I have like a novel prepared as to why I need help. Okay, I'm so ready. Let's do this.
There are 32 questions. Ready, go. 1. I attended my group meeting. True.
Yay.
Let me get out my notebook really quick before I get started here. Okay. Okay. Deciding which hypothesis test to use. Here's a list of hypothesis tests we have studied so far this semester. For each of the questions 2 through 6, identify one hypothesis test that is most appropriate to the given situation. You may use a hypothesis test once, more than once, or not at all. In an answer box, type in letter A, B, C, etc. Okay. In an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level, like high school, undergraduate degree, master's, doctorate, were people who manage successful startup companies in the United States and Korea. You want to determine if education level differs between managers of successful startup companies, differs between these two countries. Which hypothesis test would be most appropriate for this analysis? Okay.
So there's more than one sample group. How many are there? 3, right?
So we're comparing the
one that automatically being
education level of successful startup.
Because I was looking, I have that flowchart from the test saved. And
can you email that?
Yeah.
Is this a cheaper test of independence or no?
No, it's definitely not. It's definitely an ANOVA. If there's 3 sample groups, it has to be an ANOVA. Hang on, let me send it. If there's not 3 sample groups, then it's not an ANOVA, but it sounds like there are 3 groups. Hang on, let me send it. Email. Yeah. Give me your guys' emails again.
Mine's Ashlyn V, and then at Gmail.
Well, I'm going to type it in comment group chat.
Oh, that's really smart, too.
There was one that we could have filled out together. Gosh, I lost in all my boxes.
Where do you type this in at?
In this little group chat thing on the right side. Ashlyn. You figured out, Justin?
I don't think I can do it since I'm on my phone.
Okay, what's your email, Justin?
Justin.
Yep.
DC8 at gmail.com.
Okay, coming your all's way. Now, if we read this, it
She
says...
took it away.
Yeah, I totally saved that. You want to determine if the education levels differ between managers of successful startup companies between these 2 countries. So if there's only 2, then it's not an ANOVA.
Yeah.
Because it sounds like is if it just says 2 countries. So if it's 2, it could be, do we know, are the samples paired or related in some way? So are they paired? I think that they're not paired because they chose it based on that they were both companies, but not that if we chose one we had to choose the other. It's not like siblings or...
Yeah, it was, yeah.
Right.
So it's an independent sample t-test.
This one is?
Yeah. Did you guys get the graph?
Yeah.
Does that make sense?
The statistical test graph or whatever.
Yeah.
Yeah. Let me look at the email you just sent.
Yeah.
Same one I'm looking at.
I haven't got it yet. Sorry, so it's B, one sample t-test, right?
No.
Or no, independent sample t-test.
So it's D.
Yeah.
Okay. 3. A human resources manager reported data from a recent involuntary reduction in force at her company. You're an attorney and you want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years old or younger and 40 years old, and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally.
Wait, isn't that what we just did? Number 3?
No, we just did number 2.
Wait. Okay, and I thought we said that one was the ANOVA.
No, because there's only 2 groups.
Oh, okay, I'm sorry.
No, it's okay. I'm still rereading to it. Just said that they were comparing between the United States and Korea, so it's only 2 groups.
Got it.
When I first read it, I thought that it was talking about another country and those 2, but
Yeah.
it wasn't. So number 2 is definitely D, and then number 3.
Once reported the number of employees who were terminated. You want to see if they were treated equally. So
There's 2 sample groups, or is there just 1 sample group?
No,
we've got
isn't there
both groups. We've got a group where they are 40 and older, and a group where they're 40 and younger. And they are, the statistic is
Yeah,
there.
so-
The number of employees that were terminated in each group. We're going to determine if both age groups were treated equally, meaning that they have the same proportion of people. So it's a test of 2 proportions, right?
That's what I would say it is.
So how can we tell the difference?
Well, this one's very specific in stating that we're comparing the proportion of people terminated.
The proportion was kind of the key word there.
What?
The proportion was kind of the key word there.
Yeah.
So what letter was that?
2 proportions is G.
G.
Yeah. I think. Yes. Test of 2 proportions, correct?
Yeah. Is that there's 2 groups,
Yes.
right?
Yeah.
Yeah.
The survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different to the proportion of males in the population, which is 48.5%.
It sounds like one of those cheese squares.
Which hypothesis test would be most appropriate? Okay.
But the chi-square tests are testing for if things are independent or not of each other. But it sounds like so much data that would have to be in one of those things.
Yeah.
Sample of that many people completed the survey. 248 of them were classified as heavy players. of these.
They have all adults in the survey, and they have 248 as heavy. And then you have, of the 248, they also have 152 male.
It sounds just the way they set up all that other stuff, because do you remember how they give us those charts of data, and then like they had totals going across for...
Yeah.
So everybody that was heavy, they'd have a total for them, and then they'd have the totals going across the other way.
Our question is that we want to determine if the proportion of male heavy lottery players is different from the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate?
So is it G or is it H? Or is it F?
Chi-square test of independence. It almost sounds like G again.
My problem is that there's so much data in that one. I don't remember any of the other ones sounding like that. Like, there's so much data in this one.
Yeah, there is a lot of...
No, you're right. You're right.
So let's see if we can fill out this chart while we're doing this thing.
I'd say Chi sounds right. I mean, because you got multiple groups. You got the total of 2406 adults, which is split into two groups of male and female. Then you've got that split up into 248 heavy players. And the 152 were male. The other set, the other 96 were female. You've got like all these multiple different groups. So you're right. It does sound like Chi. If that makes any sense.
It kind of does.
Well, the only thing I guess I would say is a G, so that you think of the hypothesis and the alternate, and then like alternative, it's they're what is it? Is it they're different, and then your alternative would be is that they're oh wait, no, maybe not, because isn't it? It's they're independent and then they're not independent. So then
I still kind of feel like it's 8. Like the G squared, because they're
So it
trying
may
to,
not be that one.
if the players are heavy or like heavy into the lottery. I don't really understand what the freak they're trying to conduct. Like, I don't understand what the survey was even trying to. You determine if the proportion of males playing the lottery a lot is different than the proportion of males in the population.
Yeah, so you're comparing the...
Do we want to know how many people in our population are playing the lottery heavily?
I'd say it's a chi-square because you got two different populations and you've got a lot of data.
That's what I was saying. I don't really know how to phrase the question. If it's independent or not independent. Like, heavy players playing the lottery is dependent. I don't know. There's just so much
I don't know,
data.
that's why... No, yeah, because couldn't... Oh. Yeah, because couldn't you be a heavy player and a male? So... I don't know. We could just put G and C. Could you put G squared?
Are we comfortable with the Chi?
Yeah, and that's what I put.
Okay, I am too, because that's the closest thing I can think of as well. Okay, let's do 5. A student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise first, and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They want to determine if one of the locks is easier to close. Which hypothesis test would be most appropriate for this analysis?
Oh. It sounds like there's 2 sample groups, like there's 2 sampled datas, right?
Yeah, yeah.
And they are dependent on each other, so it would be a paired, right?
Is it?
Well, it would be paired because that data has to go with the same student. How long did it take them to open up this one versus how long did it take them to open?
Oh yeah, okay.
Yeah.
That makes sense.
You're right.
So C.
I was thinking paired, but then you gave your reason why, and then I was like, oh, yes, of course, yes. That's fine.
Sorry, it's sad that we had to break them down like this.
No, it's good. We need the refresher. We need to be thinking about why. Because we kind of think, oh, yeah, I think it's this one, but we can't remember exactly why. So this is good.
So it's a paired samples t-test.
Yes, so C.
C.
Yep.
Okay, number 6. Weight gain during pregnancy of the mother is an important indicator of infant health. A simple random sample of pregnant women on Egypt, Kenya, and Mexico is used to determine if weight gain during pregnancy differed in these 3 countries. Which hypothesis test would be most appropriate for this analysis?
ANOVA, right?
Is that going to be ANOVA? Yeah.
ANOVA.
That's
Letter E. ANOVA. E. Okay. Deciding which confidence interval to use. Here's a list of confidence intervals we have studied so far this semester. For questions 7 through 10, identify the one confidence interval that is most appropriate for the given situation. You may use a confidence interval once, more than once, or not at all. And the answer type blah, 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 blah. Okay. 7. A bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for this study?
the exact same thing that we did just a minute ago. This is the difference thing. So they would take the difference and compare the differences, which would make it a paired.
Paired sample.
Yep.
Paired sample T confidence interval. So C?
Yep.
In a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied or very satisfied with their career path was reported. The same data was also reported for accounting majors. You decided to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this study?
That's such a good question.
So it's the same thing that you're checking, but it's with 2 different groups that are independent. So it would be
An independent
Doesn't
sample
it
T.
look categorical? Isn't there a difference between the tests that are categorical and the ones that aren't?
Yes, there is.
Well, you've got 2 different groups, psych majors, and you're looking at the percentage that were satisfied or very satisfied. So you're not looking at just the category, but you're looking at the percentage within the category.
Yeah, but all the categorical ones come down to math too. Like it's just how they report their answers.
Yeah.
It makes it categorical.
The category is yes or no instead of like numerical where it's like
A number.
Yeah.
Of
yeah.
Are you satisfied on a scale of 1 to 10? Or are you satisfied or not satisfied?
Mm-hmm.
So I think that we're looking at F, aren't we? Or how many groups are there?
2. One of there be 2
There's
groups
2.
satisfied and very satisfied.
So it would be F, wouldn't it? We could talk about this. It doesn't mean that I'm right. That's just my train of thought.
Explain to me why, again, sorry. Let me
So,
see.
The
Make sure I
difference between the quantitative that we have been doing with the Z and T regular scores and the proportions is that they're categorical versus quantitative or whatever. And so because the answers were submitted as satisfied and very satisfied, that would make it categorical versus numerical. Because this could be displayed in one of those weird bar graphs.
No, you're right.
Percentage, but it would be satisfied versus very satisfied. And so it's still, we're still getting like the percentage of our answers, but our answers are not numerical, which would make it a proportion of 2. So it'd be F, right? I could totally be wrong, but if someone has to explain.
No, I think that's a good explanation.
Okay.
You're right, F. Thank you.
No problem.
Well done, teach.
If we're wrong about all this in the end, I'm very sorry.
It's okay. I feel like I learned something, even, No. All right, let's do 9. O'Hare International Airport in Chicago has a reputation for having a large proportion of its flights being late. Thank you, Midwest storms and Great Lakes and stuff. You design a study to see if this reputation is deserved. You find that the average on-time rate for all international airports in the U.S. is 70%. You collect data and determine the on-time rate for O'Hare. You decide to construct a confidence interval to compare O'Hare's on-time rates to the national average. Which confidence interval would be most appropriate for this study? Let's see.
It still sounds like a difference one, which would be a paired. But I feel like everything's a paired.
Well, let's take a look at this. So you find the average on-time rate.
And then you compare it to the national average.
So,
Well, no. So is it on time and not on time, or is it they are 70% on time? Does that make sense? So I feel like they're saying that 70% of the airports in the United States is on time. Is that what they're saying?
Oh, okay.
70% of the flights to airports in the United States are on time.
Are on time, yeah.
That's categorical, right? And then it says you collect data to determine the on-time rate for O'Hare, where it might be 50% of their flights are on time. We're not finding out exactly what time they get there, but if they're on time or not. Is that how they're doing this?
yes.
Yeah.
Good.
So is this a +4 for 1 proportion or 2? So we're comparing the proportion of
I think
O'Hare
you're
to the
not.
rest
Yeah,
of the
I
United
think
States?
you're comparing. You're not like. So the other one you were like seeing the difference, but I just think this one you're comparing. So.
So is it F again then? Because it's the on time versus the not on time. Right?
No, but we're only. I think doesn't it only say that we compare the on time, and we can search an interval for an interval for an on time. So we're not looking for both. I just think we're looking for one.
So E?
No. The on-time rate. Maybe it's either E or F. I'm not sure. I wish I had notes for that. You know?
So what we're doing is we're comparing the on-time rate that this airport gets versus the on-time rate that all the other airports get. So that's,
Yeah. See, that sounds like you're preparing like a sample to the.
well, what we're trying to prove is if one particular airport meets what the average is. So I think that that's just one proportion, and that we got our from what all the other ones is. Right?
Yeah. That's what I think, but I don't know.
Because it's just saying that they already found the average for the international airports is 70%. So we collect the data for the O'Hare and decide what's their rate, on-time rate, and then we want to compare the two.
Well, that sounds right. I like it. Let's do it.
So E.
I don't feel as confident about this one, but
E. So we're gonna do E. Confidence interval for 1 proportion.
do you guys remember this example from earlier in the semester?
It sounds.
I remember. Yeah, it sounds familiar.
Over this. And it wasn't part of our proportions, it was part of the paired samples when we did it the first time. Or it might have been the one sample T confidence, but do you remember that?
Yeah, that's what I thought at first, but I wasn't. I don't know. I thought it was maybe like.
They used this exact example before. In fact, we even had we downloaded the data off of the file.
That's right. Yeah.
I wonder if I could find that old paperwork and see what section that was for and see how it was worded. I don't think it was homework. I think it was a group assignment. Let me see. I kept most of them.
Yeah, I think it was on a quiz.
I'm just going to check really quick. See if I can find it. found the one for the National Realtors. Assembly signs. I didn't see it. It must have just been on the quiz. I just feel like we went over that way more recently.
You guys feel confident in it being one proportion? Because I'm not sure, and I don't have the notes.
I feel like she's making it seem like it's categorical, but I remember this data, and it was data that we collected, like on the exact same airport stuff. And I think it was one of the other ones, but
I just feel like the way that this question is phrased, though, it sounds categorical, since we actually haven't been given. Because we're not, I don't feel like we're comparing, like, data, we're comparing whether they were on time or not.
find the average on-time rate for all international airports. Collect the data and show the on-time rate software. Describe the constructive confidence interval. We are just comparing the values, but I don't think that that means necessarily that it's categorical. Because there's still numerical things that we're comparing.
Okay. In that case, it wouldn't be a +4, correct?
Exactly. So I'm just trying to analyze it. So even though they're talking about just comparing, we're comparing a numerical value. So it can't be categorical.
In which case, it would be a one sample T? Or is it two things that we're comparing?
Well, we have to compare the time that they were supposed to arrive with the time that they did arrive, right? And then we're comparing. I just have to decide. We have to decide if that's what we're comparing, or if we're just going to compare that value afterwards. So that if we're just comparing differences, which is still a paired sample. They all seem like freaking.
When it says we're comparing O'Hare's on-time rate to the national average on-time rate. That's what we're comparing.
So we didn't have to collect the other data, but if we're comparing the on-time rates, that means that we would have had to figure out what the difference. Oh no, we would have just had to decide if it was on time or not.
Yes.
So I'm going to say probably the one sample T, right? B.
I'm not sure at all.
That's I was just trying to read over refresh my memory of a one sample T, because that's what I was thinking it was.
One sample T is two samples, unknown independent samples.
So the one sample T compares the mean score of the sample to a known value, which is usually the population mean.
That sounds right. So which one was that? The one sample T?
Yeah.
So the mean score for this, so it says the mean score. So we're saying that the mean score is 70% are on time. That's the average on time rate. 70%.
Yeah, see, that's what I was thinking.
For that. We're comparing.
Yeah.
So the one sample T confidence interval.
That sounds right. I'm a lot more confident about that.
Okay. Double stuffed Oreo cookies are supposed to have twice the filling. So, okay, before I move on, 9 is B then. B, 1 sample T. Okay. Make sure everyone heard. So, 10. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is true assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You want to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study?
Well, we're just collecting the double stuffed one for now, so is it an A? Because we're not comparing it to the mean or an average.
So the confidence interval we need to construct is used to estimate the true mean filling amount of double stuffed Oreos, which would be a 1 sample Z confidence interval.
What it sounds like.
Yeah.
Let's do it. A. All right. 11. Which of the following best defines the notion of the level of significance of a hypothesis test?
Is that one A? Or the first one, the probability of rejecting the null, whether it's true or not?
I thought that it was...
The probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true.
Because that's why you have a level of significance. I think the probability of rejecting that's the p-value, not the level of significance. So it'd be B.
Yes.
So it's the p-value?
P-value is A. The probability of rejecting or not rejecting.
I thought the p-value was the probability of observing a sample statistic.
Oh, well, let's think about this.
Well, of observing a sample test more. Maybe you're right.
I think you're right. I think you're right.
Okay, so I got them backwards. So then it is A, and then p-value would be B then. Right?
Yeah.
P-value is one of them.
Yeah, I think the p-value. I have it right here. P-value is compared to the level of significance. What is? Let's see here. No. P-value, the probability of obtaining a sample mean or test statistic at least as extreme as the one you calculated, assuming the null hypothesis is true.
Cool. So p-value is B. That would mean that A is the notion of the level of significance.
Okay.
The notion of level of significance of a hypothesis.
So 11 is the probability of rejecting the null hypothesis, whether it's true or not.
I don't really like the way that question's worded.
Yeah.
So is a p-value the notion of the level of significance of a hypothesis test? Never mind. It's cool.
I don't know. I hate how it's worded.
That question's worded really bad. But it's okay. I think we're good. I'm good with that.
Is it the probability of a type 1 error?
No, I think that they just throw those in.
Well, yeah.
Let's see.
I don't think it is, but I think that if you play with the level of significance and you just increase your like type 1 error, or you decrease, or like you can decrease your type 2. So it just depends on how you move it on what you do.
Yeah, those two interact with each other that way. But oh, look, the next one is what we were talking about.
C.
Yay! So I think we were right.
Okay. 13. 13. Suppose you create a 95% confidence interval for a mean and get 10, 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. What exactly does this mean?
Isn't it C?
95% chance that the true mean is between 10 and 20.
Or yeah.
Yes, because it talks about the true mean.
Yeah.
That's what it's all about, is finding the
The
true
other
mean.
ones are absolutes. This one is there's a chance. Right?
That's true. I didn't think of it that way.
Questions 14 through 16. You take a simple random sample of 100 adults from a town in the western United States. Sorry. 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion of, or percentage of people in town who invest in the stock market is P equals 0.3, or 30%. So what is the mean of the distribution of sample proportions?
What? 80?
Is it a 0.30?
Isn't that P?
So we've got 100 adults that we're sampling, and we want to know the proportion, to determine the proportion of those in town who invest in the stock market.
So P is equal to what the U used to be, that fancy U.
Yeah.
Mu P
So
hat.
the mean
30?
of the distribution should be 0.30, because we're looking at
Yeah,
it, right?
Yeah.
that's what I thought.
They should be equal to each other.
Yeah, they are.
Yeah.
That's what I have in my notes.
30 the answer, or 0.30? Because we're surveying
0.30.
100 adults.
Well, the mean is 0.30. I think that we're using all that information on 14 through 16. So I don't think we have to use the 100 adults until later. What is the standard deviation of the distribution of sample proportion? So I think that I don't know, I just have that mu is equal to P in my notes. P is
And
the
that's what I have as well.
So P is just the
That's what I have.
population, the parameter of interest. It doesn't necessarily mean that we're going to tally it out and times it by our sample right away. That would
You're
be
right.
something else. So 14 is D.
14 is 0.30.
Yep.
15. What is the standard deviation of the distribution of the sample means?
So
The square root of P times 1 minus P over... Oh, we don't have
N.
X, do we? Oh, no, it's N. Just kidding.
No, you don't have to. Yeah, it's N. It's not X.
P times 1 minus P all over N, and then you take the standard deviation. So let's see.
So P times 1 minus P all over N?
Yeah.
Yes, and the square root
And then you
of
take
that.
the square root.
I got 0.046.
That's what I got.
I feel pretty good about that since that's an answer.
One second.
So what'd you guys get?
0.0458.
0.046.
Yep.
0.046. 16. What is the probability that your random sample of 100 adults will have a sample proportion less than 0.25? Was it 0.25 minus 0.30?
All
Over
over the standard,
0.30.
right?
Yeah. Yep. And that'll give us our Z, then you plug it into the
All over the
applet.
standard deviation, you said?
Yeah, all over the standard deviation. Our z-score is negative 1.087.
Sorry, what was that? What did you get?
Negative 1.087.
That's not an answer, which sucks.
No, so
no.
that's your z-score. Then you got to
So
plug
then
it
I
into
didn't
the
want to-
applet.
The area would be 0.
Oh, they have to plug it into the applet.
Yeah. Is 136 an answer? 138?
Yeah, I got for my z negative 1.091.
Yeah,
Maybe
me too.
I think
That's
I
what I got. So
You guys did 0.25.
1.3. Oh, I see. I got
So wait.
0.3 right over the standard deviation.
So you guys did 0.25 minus 0.30, which is negative 0.05, all over the standard deviation. And then you plug that in as a z-score, right?
Yeah.
Maybe I just rounded mine too soon. Yeah, I
So
just rounded mine too soon.
0.1376.
Yeah,
So for mine, sir.
So 0.138. 0.1.
Yeah, that's what I got.
Yeah, that's what I get.
A. Yeah.
Okay.
Well, I rounded too early and I was close. Go ahead.
For questions 17 to 21, use the following information. Acupril is meant to control hypertension. In clinical trials of Acupril, 2142 subjects were divided into two groups. The 1563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1563 in the experimental group, 61 experienced dizziness as a side effect. 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but do not take Acupril. Create a 95% confidence interval of P1 and P2. We can use that Excel file, right?
Yep.
Yeah, so you use the Excel file. And I got C, negative 0.004 and 0.029.
You're really fast, Justin.
Sorry, I went ahead and did this today just so that I could be more on top of it.
You're good, man.
I'm sorry we're taking so long.
No, that's okay.
Proportions test, right? So you said you got C, negative 0.004.
That's what I got.
And 0.029.
That's exactly what I got.
Okay.
Okay.
Perform a hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different from the proportion of control groups. Let P1 be true while taking Acupril. Let P2 be true for experience dizziness but do not. Let a level of significance of alpha equals 0.05. What is the hypothesis test? We're trying to see if
It's different, isn't it?
sorry.
Different. So it would be B, right?
P1 equals P2 and P1 does not equal P2?
Yeah.
Yeah, that's what I was thinking.
I agree. 19, the value of your test statistic is?
Hang on, I need to change mine.
1.458.
Yep.
Sweet.
Awesome. The p-value of your test is?
Hang on. P-value is 0.145.
Sweet.
So, is there sufficient evidence to conclude the true proportion of people who experience dizziness while taking it is different than people who experience dizziness while not taking it?
Yes, because our level of significance was 0.05. Oh wait, does it have to be smaller?
It has to be
Yeah.
smaller. So, no, I reject
Yeah,
it.
so.
Yeah, I'm having a blonde moment. It's been a long day.
You're alright, it's okay.
So is it no,
I
I rejected it?
the null hypothesis.
Yeah.
I don't even have that as an option.
It's the fourth one.
No, I rejected the null.
No, we wouldn't reject the null. We would reject
Would you fail to reject?
We would fail to reject. If it was a high number?
Sorry. No, I failed to reject the null. Sorry.
Yes.
Yeah. There's my blonde moment, too. Okay, no, I failed to reject the null. Okay, a survey was conducted of 1,279 randomly selected adults aged 18 and older. They were asked, are you a morning person or a night person? The hypothesis for this study are being a morning or evening person is independent of age, and being a morning or evening person is dependent of age.
This is a chi-square.
That's what it sounded like, yeah.
It totally is because it's independent. Sorry. So what are we doing? Oh, we're going to plug that in.
I'm entering the information really quick.
I'm not going to lie, I was pretty relieved that we didn't have to do anything this extreme for our group projects.
So, yeah.
Yeah.
I was terrified that she got all this data from previous projects. I was like, this is going to be
Seriously?
Yeah, that's exactly where my mind went.
Calculated test statistic. 6.58.
Yep.
Woohoo! 23. Calculate the p-value for this hypothesis test. The p-value is 0.0866.
That's what I got.
So 0.087?
So is it 0.0866 or?
0.087, because the other one's 0.866.
Yeah, because there's a 0 first. 0.0.
We're rounding to 3, 0.087.
Hang on, so, oh, never mind.
24. Did you reject the null hypothesis or not? Nay.
No, the p-value is greater than 0.05.
0.5.
Yeah. Okay. 25. Do you have sufficient evidence to conclude the age makes a difference in whether a person is a morning person, a night person? Why or why not?
Is it no, I failed to reject?
Or yes?
Hang
Oh, wait.
on. So, what was our null hypothesis?
Oh, wait.
null
Hold
hypothesis,
on.
being a morning person or an evening person is independent of age. So our null hypothesis was saying that it doesn't matter how old you are. Our alternative hypothesis saying being a morning or evening person is dependent on age. So we proved that the null hypothesis is true, so it's independent, so your age doesn't matter.
Yes, so no, we did not. So it says, do you have sufficient evidence? And our answer is no. We do not have sufficient evidence that age makes a difference because I failed to reject the null.
Wait, it says, do you have sufficient evidence to conclude that age makes a difference? But we do have sufficient evidence.
Oh, you're right. So yes,
Yes.
yes, I have sufficient evidence.
And we failed to reject.
Good catch.
Make sure you do failed to reject because the null is true.
I feel like that question could be worded better. Do you have sufficient evidence in regards to the question whether or not age makes a difference in whether a person is a morning person or not?
The issue is that the answers are lazy. The answer should have said, yes, I have sufficient evidence.
Yeah.
I failed to
it's all lazy. Like,
Yeah, this is the new answer. You say, like, yes, I have sufficient evidence. And so they just, it's weird. They, like, took it out.
Yeah, they just
They asked the question.
so yes, I failed to reject the null hypothesis.
Yeah.
Okay. Questions 26 and 27. A recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business schools of the Dow Jones over a 5-year period.
Wait, I like totally don't even know their F.
So this is our P tilde plus or minus Z
Oh, the
times the square root of P tilde times 1 minus P tilde over N plus 4. I think that's what I did.
So the P squiggle plus or minus Z times that crazy thing.
Well, we can do the math again. But what did you get?
So let me see here. I actually didn't even write my answers down. Sorry.
That's okay. What's the equation?
No, I think I got C actually. So I put 0.256 because you have to figure out your P tilde, which is x plus 2 over n plus 4. So you've got 52 over 204.
So 0.195 and 0.315?
Yeah.
Okay. You guys comfortable
So
with 1 to 27?
Yeah.
Yeah, so I just did it again, and I got for the upper limit 0.315.
Cool.
88905.
Cool.
Okay. So suppose you have been in charge of designing the study. What sample size would you need to construct a margin of error of 2% with 95% confidence?
Now you just look for N. Or like you do.
You do the NP is
Yeah, there you go. Yeah.
greater than or equal to 10. No, that's not right. Is that
No, so
right?
you go your Z over M squared times P times 1 minus P is what I did.
Can you say that again slowly?
Yeah, so N equals Z over M, and then that is squared, times P times 1 minus P.
Yeah, the P is different.
That equals N?
Yeah.
Yeah.
So we're looking at 0.2 for P?
That looks like it.
Yeah.
And then it'd be 1.96, right?
Correct.
And then 0.02 squared times that times that. Well, this should be fun. Sometimes I feel like, who in the heck made this up?
Yeah.
Yeah, how did they come to know that that was true?
Yeah. And I think they didn't have calculators. That's really more crazy.
98 squared? Seriously?
I have 16 because you have to round up. 15.424 and you round up to 16.
I
got 1537.
Yeah. 0.2 times 0.8 is 0.16. And I multiplied that by
4 times 0.16. So I got, this is how I wrote it out, 1.96 all over 0.02, and then you square that, so that's 98 squared is 9,604 times 0.2 times 1 minus 0.2. So that little side thing is 0.1. Because 0.8 times 0.2 is 0.16.
Oh,
So,
right. What did I press wrong?
Yeah.
I don't know. It's kind of
How was
tricky
it
that
an
that's an answer.
Yeah.
Stupid. I typed it in wrong.
So 15. I just did it again, and now I got 1536.64. So 1537.
Yeah.
Okay, perfect.
So many numbers. I get lost. And then I get it wrong.
You're right. When I went back over that, I was like, how did I go from 90 something hundred to
16.
So thank you.
No, it's good. We're all helping each other.
Use the following information for questions 28 through 32. Suppose you wish to see if there's evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct the hypothesis test. Level of significance. Which of the following pairs of hypothesis is the most appropriate for addressing this question? Or let me see if they perform better.
Better than? Would
so
that
it'd
be greater than?
Greater than.
So that's 3.
3. Hypothesis null. P equals 0.2. Hypothesis alternative is P is greater than 0.2.
Yeah.
Okay. The 29. How many measurements must you have in order to assure that P hat is normally distributed?
Isn't it 5?
Yeah, just
Greater than 5. Yeah.
N is greater than or equal to 5?
Yeah.
Yeah.
Okay. The value of your test statistic is...
Seriously? Do you have enough information for this?
I don't know. I'm reading
Yeah,
it.
so you've got to go Z equals P hat minus P over your P times 1 minus P over N, and that's
Oh, the standard deviation.
square root. Yeah.
So P hat, what is P hat?
Is it?
It's X over N.
Yeah, so that's 50 over 200, which is 0.25.
50 over 200.
Minus 0.2 all over the standard deviation, which we decided was what? We haven't. Yay.
So you said 50 over 200?
Yeah, so 0.25 minus 0.2 all over, and then it was 0.2 times 1 minus 0.2 all over 200, and then you take the square root. There's just, whoever came up with this.
What's 0.05 over?
It's, oh. Yeah, over the standard deviation, which is 0.2 times 1 minus 0.2 over 200, and then you take the square root of all that. And the square root
The square root of the denominator of the whole thing?
of the
Just
just
the
the denominator.
Yeah.
So it's kind of just like all over the standard deviation, if you remember what that
Yeah.
was.
You guys go. No. Ah, stupid.
I got 3.162. That's not even an answer.
I know. I got something that wasn't even an answer, so I'm doing it again.
Okay, I got 1.768.
How did you get that?
So your top number is going to be
0.768 as
0.05.
well.
Wait, say that again?
So your top number is going to be 0.05 over the square root of 0.0008. So then when you do the square root of that, it's 0.028284271.
Just 0.5 over that.
Yeah.
I got 1.76778, so 1.768.
Yeah, that's what I got.
How do you figure out the p-value? You gotta...
So now you go into your applet.
Okay. And we're looking at then, aren't we?
Yeah.
Well, let's see.
So 0.039.
Yep.
So we're looking at the probability that P will be greater than 0.2. And that is 0.039, right?
Yep.
Yeah, that's what I got.
The p-value of your test is... Hey. Oh, I already got that. 1.768 and then 0.039. Okay. Test statistic 1.768 and p-value 0.039. I want to make sure I didn't press that wrong. Okay. Is there sufficient evidence to conclude that graduates from top 10 business programs perform better than other investment managers?
P is less than alpha, right?
The first one?
So, yes, I rejected the null.
Wait. Is there sufficient evidence to conclude? So yes, and then we
rejected the null, saying that it was equal, but it's not. It's greater.
So it's A, right?
Yep, A. Yes, I rejected.
Yeah.
Well, I just submitted.
Me too.
Eh,
I got a 75.
I got a 72. I don't know what I did wrong. Oh.
Well, we definitely didn't understand all of the
definitions.
Go back through.
That's what I suck worst at, is the definitions.
Me too.
All right. Hey guys, I gotta get running. Sorry. I guess I'll have to do a lot of studying before I take the exam.
So for the group project, really quick this week, is it just the I can't remember what we have to do, but just
You have
one
to
person.
run the data, right?
Yeah, so whoever's over that, that person just has to submit it this week, right?
Well, I think she sent out an email saying everybody has to submit it.
Which is that person's in charge of leading that section.
Yeah, so I think that's
Okay.
me. I'm pretty sure this is me. And I'll read over it. If I need any help, I'll just shoot you guys a text.
Okay. Yeah, feel free
Okay,
to text
perfect.
everybody, and we can keep this going.
Yeah, I think it works really good with the Google Drive because we can all get on there and type it, and then I can just send the document in.
And just kind of like let us know, keep us up to date in text, and let us know when to go in and edit our own little bit.
Yeah, I'm going to copy and paste the document that's in the file right now onto a Google Drive so everyone can kind of see it, and then I'll shoot you guys a text if I need any help.
Perfect.
Awesome.
All right, guys, I'm gonna go.
Hey, Victoria,
Yeah,
can you resend me the email? Mine never came through.
it's ashlynv@gmail, right?
Yeah.
Yeah, I'll do it one
Is
more
it
time.
is it 2 N's?
Yeah.
Okay, then weird. Okay, sorry. Thanks, everyone.
Okay, no problem.
Awesome.
Bye.
Bye, guys. I'll
See ya.
if
All
we
right, bye, guys.
Bye.